This is a quick and dirty teardown of a StarTech USB 3.1 Gen 2 dock, model DK31C2DHSPD. First, to disassemble it, you remove the 4 rubber feet at the bottom, undo the screws, and pry off the top. It's held in with a few plastic snaps. Once you've got the top off, you undo 2 screws at the center of this top shield. Then the shield can pull straight off. There's 2 little adhesive thermal blocks that are sitting on top of the main board. The main board is held somewhat securely to the bottom. You'll want to undo the rubber around the reset button on the side. Once that's released, then you can kind of push up and push the main board out, and then if you want, you can peel this foil with a layer of insulating plastic that was sitting against the bottom of it off to see the PCB. Alright, now for an overview of the components on this PCB. I'll get my notes in my lap so I can talk you through this. So we'll start from the most upstream, the USB port that connects to the computer, and go from there. The USB port enters here, which is a TUSB64 IC. There's a few similar ICs that have documentation online. It seems to be a DisplayPort and USB switch and redriver, so it just breaks out the DisplayPort and USB signals and redrives them, boosts the and clarifies the signal. Video then lands here on the Synaptics VMM5320. This breaks the DisplayPort signal out into 2 DisplayPort ports and an HDMI port. It claims it can do 4K 60 to both ports. I assume there's the inherent USB-C bandwidth limitations with that. USB data, on the other hand, makes its way to this IC, which is a Genesis GL3590. It's a USB 3.1 Gen 2 hub. Then 2 of those 4 hubbed ports go here and here to these 10 gigabit per second USB ports. You can also see there's some power delivery circuitry by them so that they can do fast charging to connected devices. So you got a coil here. Back here you've got some this is a DPS 1133 USB power delivery controller with built-in MOSFETs. A third of the USB 3.1 Gen 2 hub lines goes to this SD card IC, which is a Genesis GL3227 to this SD card port. So that's going to be a very fast SD read. The 4th one goes to an additional hub here, which is a Genesis GL3523, a USB 3.1 Gen 1 hub. 2 of those slower USB ports go here. I'm not sure where the 3rd one goes. Maybe it makes its way back across the PCB to the controller ICs, which I'll talk about later, or something else. It also connects to a Genesis GL850G USB 2.0 hub, and that drives the USB 2.0 ports, these 2, and probably connects to the 3.5mm headphone jack, which itself is a Realtek. Let me look here at my notes. I found that to be a Realtek ALC 4042, just a pretty generic audio IC that could also do SPI and other interfaces if the designers wanted to. Now, as for control of this, there are 2 very similar ICs, and I don't know why there's 2, which is interesting. They are both by Infineon Cypress. One is a CYPD 4236. The one to the right is a CYPD 3125. They each have 128 kilobytes of flash, 8 kilobytes of RAM, can do some USB-C power delivery control, and have an ARM M0 microcontroller core in them. The 3125 also might have slightly better USB client capabilities. So obviously they're controlling the show here. and controlling the USB power delivery. This PCB has quite a lot of layers, so it's rather difficult to actually see exactly what they're connected to. I'll assume that since this 3.1 Gen 2 hub is busy, they're actually connected pretty far across the PCB to the 3.1 Gen 1 hub. Could be wrong, of course. Other things of note, got some random SPI flashes sitting around, so that way some of the fancier chips can have their firmware. In theory, I guess that means they're firmware upgradable, although I'm sure they won't bother. Of course, got some inductors and little MOSFETs for power delivery. I already mentioned for the USB client ports with high-speed 3.1 Gen 2 data. They've got some power delivery stuff going on here for fast charging. They're actually labeled as such on the box, like so. On the back, there's not as much mention of that. As for the rest of the power delivery, it comes in here through this barrel jack. You can see here it's a capacitor. These four little ICs are MOSFETs, got some coils. This IC right here, if I look on my info, is an onsemi NCP 81239. It's a USB power delivery booster converter. So this is probably what's controlling the show and enabling 100-watt charging back to the host device. The reset switch is all the way over here, so there's got to be a little line that makes its way all the way across the PCB to those controller ICs back over here. Power status LED right here, pretty conveniently close to the controller ICs. And that's about it. Took a little time to reverse engineer this. The layout and architecture are similar to other docks I've disassembled, although again this one's got a ton of layers. You can really see how there's a few components that are seemingly connected but don't have super obvious traces or go all the way through all the layers to the front and back. And just otherwise rather interesting. If you want a brief review of this dock, it does randomly disconnect on me. It could also be because I have a hub upstream, but I also get network disconnects. So I'm assuming that this is either overheating, buggy, or whatever. I have not had great experience with used StarTech USB-C docks in the past. So what I'm going to do is I'm going to use some thermal glue and some cheap heat sinks to see if I can cool these ICs better and if they are happier that way. No clue if that will help, and that I'm not sure how well heat flow will work because there are these, I'm assuming, EMI shields on the front and back that I should probably replace for my own good, but I will see what happens. Also interesting is that the EMI shield is attached by these foil and foam blocks. These blocks are all connected to the same ground plane as one would expect. So it's interesting that these are still here just, I guess, for RF shielding and that shielding extending to the cable, making part of that same plane. But yeah, somewhat interesting.